Hello, welcome back to Civil Engineering Edge. We are deep diving into this video, building components in civil engineering and their function. As you confirm, we will continue with each component: foundation, plinth, columns, beams, etc. one by one. Parts 1. Foundation. In civil engineering, the foundation is the most critical part of any structure. It is the lowest portion of a building, responsible for safely transferring the load of the entire structure to the soil beneath. Without a strong foundation, no building can stand the test of time or environmental stress. Foundations are designed based on the type of soil, the load of the building, and environmental conditions. There are two major categories: shallow foundations and deep foundations. Shallow foundations, like isolated footings, combined footings, and raft foundations, are used when strong soil is available at a shallow depth. Deep foundations, such as pile foundations or pier foundations, are adopted when the surface soil is weak and the load must be transferred to deeper, stronger layers. A well-designed foundation performs several important functions. It ensures stability, resists movement caused by wind and earthquakes, prevents uneven settlement, and safeguards the building against soil moisture and frost action. Proper soil investigation, bearing capacity analysis, and structural load calculations are essential in foundation design. Additionally, a foundation must be built using durable materials like concrete, reinforced steel, or stone masonry, depending on design and budget. Waterproofing and soil treatment may also be applied to prevent long-term deterioration. In summary, the foundation is the unsung hero of any construction project. Though it lies hidden underground, it is the very base that supports everything above. A strong foundation means a safe, long-lasting, and resilient structure, the first step toward engineering excellence. Parts 2. Plinth and DPC. Once the foundation is complete, the next vital building component is the plinth. The plinth is the part of a structure that sits just above the ground level and acts as a base for the superstructure, typically the walls and columns above. Its main purpose is to raise the structure above the surrounding ground level, protecting it from moisture, floodwater, insects, and soil erosion. By providing a clear separation between the foundation and the main structure, the plinth prevents direct contact with ground moisture, which can cause long-term structural damage. The height of the plinth usually ranges between 300 millimeters to 600 millimeters, depending on the location, ground conditions, and building type. In flood-prone or high rainfall areas, the plinth is often raised higher to avoid waterlogging issues. Now, integrated with the plinth is an important protective layer called the damp-proof course, or DPC. This layer is typically made of waterproof materials like bituminous coating, plastic sheets, or dense cement mortar. It is laid horizontally at the plinth level, just above the foundation, to block the upward movement of moisture through capillary action. Without a DPC, moisture from the soil can rise through the walls, causing peeling paint, mold growth, and weakening of structural materials over time. Together, the plinth and DPC act as a defensive layer, protecting the superstructure from ground-related issues. Though small in size, their role in enhancing the durability, safety, and lifespan of any building is incredibly important. Parts 3. Columns. In civil engineering, columns are one of the most important structural components of a building. A column is a vertical load-bearing member designed to transfer the weight of the structure, including slabs, beams, walls, and even occupants, down to the foundation safely and efficiently. Columns are primarily subjected to axial compressive loads, meaning they carry weight vertically. Their design must ensure that they do not buckle or fail under the heavy pressure from upper floors. Columns also help resist lateral forces during events like earthquakes or strong winds, making them essential for the overall stability and integrity of the structure. There are different types of columns based on shape, such as rectangular, square, circular, or L-shaped. Reinforced cement concrete, or CC columns, are the most widely used, combining concrete's compressive strength with steel's tensile strength. The placement of columns must be carefully planned by structural engineers. A mistake in column positioning can lead to inefficient load transfer or architectural limitations in interior space. In short, columns are the backbone of a building's framework. They stand tall, silently carrying massive loads and ensuring the entire structure stands firm for decades. Parts 4. Beams. In civil engineering, beams are critical structural elements that work alongside columns to form the skeleton of a building. A beam is a horizontal member designed to carry loads from slabs, floors, or walls and transfer them to vertical supports like columns or walls. Beams are primarily subjected to bending moments and shear forces. Their function is to resist these forces without deflection or failure. This is why accurate calculation of span, depth, reinforcement, and loading is essential when designing beams. There are various types of beams used in buildings. Simply supported beams rest on supports at both ends, while cantilever beams extend beyond a support, carrying load at the free end. Continuous beams span across multiple supports, providing greater stability and reduced deflection. Materials used for beams include wood, steel, and most commonly, reinforced cement concrete or CC. Beams can also be categorized based on their position, such as lintel beams above doors and windows, plinth beams above the foundation, and tie beams that connect columns at the same level to reduce buckling. Proper reinforcement inside beams, typically with steel bars, is crucial. These steel bars resist the tensile forces while the concrete handles compression. Together, they ensure the beam remains strong and rigid under load. In essence, beams are the horizontal highways of force within a building. Without them, load distribution becomes uneven, leading to instability. Strong, well-designed beams ensure your structure remains safe, balanced, and enduring for generations. Parts 5. Walls. In civil engineering, walls serve both structural and functional purposes in a building. They are the vertical elements that enclose spaces, support loads, and divide areas within the structure. Depending on their design, walls can either carry structural loads or serve as non-load-bearing partitions. Load-bearing walls carry the weight of the structure above them, such as slabs or roofs, and transfer it down to the foundation. These walls are usually constructed using bricks, stone masonry, or reinforced concrete. On the other hand, non-load-bearing walls, also known as partition walls, are mainly used to separate rooms or create interiors without contributing to structural support. Walls also act as barriers to weather, preventing rain, wind, and dust from entering the building. Proper wall construction ensures thermal insulation, soundproofing, and fire resistance, contributing significantly to occupant comfort and safety. There are many types of walls in construction: masonry walls, concrete walls, drywall panels, and even glass curtain walls in modern architecture. The material selection depends on cost, climate, structural needs, and aesthetics. In addition, walls play a key role in aesthetics and design. Through plastering, cladding, painting, or tiling, they shape the interior and exterior look of the building. Special care must also be taken to include openings in walls for doors and windows without weakening the structure. Ultimately, walls do more than divide space. They provide protection, stability, and identity to a building, forming the living framework within which people reside and interact. Part 6. Floors and slabs. In any building, floors and slabs create the horizontal surfaces where people walk, work, and live. Floors separate different levels of a structure and must support all live loads, such as people, furniture, and equipment, along with their own weight, called dead loads. A slab is the flat, usually reinforced concrete, element that forms the floor or ceiling of each level. Slabs distribute the load to supporting beams or walls, which then transfer it to columns and foundations. There are several types of slabs based on their support and structure. The one-way slab spans in a single direction between beams, suitable for rectangular spaces. The two-way slab supports loads in both directions, commonly used for square or nearly square spans, offering more rigidity. Slabs must be designed to resist bending, shear, and deflection while maintaining durability. Reinforcement with steel bars helps slabs manage tensile stresses, as concrete alone is weak in tension. Floors also contribute to the building's insulation, soundproofing, and fire resistance when appropriate materials and finishes are applied. In modern construction, various floor finishes like tiles, wood, or carpets are applied over slabs to enhance comfort and aesthetics. A properly designed floor and slab system ensures structural safety, occupant comfort, and longevity. It connects spaces vertically and provides the essential platform for all human activities inside the building. Floors and slabs are truly the foundation of our everyday experiences inside buildings. Part 7. Roof. The roof is one of the most important parts of a building, providing the top covering that protects the entire structure from weather elements such as rain, sunlight, snow, and wind. Roofs come in various shapes and types: flat, sloped, pitched, or curved, and their design depends on factors such as climate, aesthetics, and the building's purpose. For example, sloped roofs are common in areas with heavy rainfall or snow, allowing water to drain easily, while flat roofs are often used in dry climates or modern architectural styles. Structurally, the roof system includes the roofing material, support framework, and insulation. The support is usually provided by trusses, rafters, or beams that transfer loads to the walls or columns. Besides protection, the roof plays a vital role in thermal insulation, preventing heat loss in cold climates or excessive heat gain in hot areas. Proper insulation and ventilation in the roof reduce energy consumption and improve indoor comfort. Roofs may also accommodate additional functions, such as housing solar panels, rainwater harvesting systems, or even rooftop gardens, contributing to sustainability. Waterproofing is crucial to prevent leaks and damage to the building interior. Common roofing materials include tiles, metal sheets, shingles, concrete, and bituminous membranes. In summary, the roof is the ultimate shield for a building, safeguarding occupants and structural components while contributing to the building's energy efficiency and design aesthetics. Part 8. Doors and windows. Doors and windows are essential components of any building, providing access, ventilation, natural light, and security. Though often overlooked as simple openings, their proper design and placement are crucial for the comfort, functionality, and safety of occupants. Doors serve as controlled entry and exit points. They must be strong enough to provide security, durable to withstand daily use, and properly sealed to prevent drafts, dust, and noise. Doors come in various materials such as wood, steel, aluminum, and PVC, each offering different levels of strength, maintenance, and aesthetics. Windows play a vital role in allowing natural daylight and fresh air inside buildings, improving indoor air quality and reducing dependence on artificial lighting. They also contribute to the building's thermal performance by allowing solar heat gain or providing insulation, depending on their glazing and framing materials. Placement of doors and windows must balance privacy, ventilation, security, and aesthetics. Proper sizing and orientation ensure optimal sunlight penetration and cross-ventilation, improving energy efficiency and occupant well-being. Modern buildings often include features like double glazing, thermal breaks, insect screens, and safety glass to enhance performance. Besides functionality, doors and windows also influence the architectural character of a building. Their styles, shapes, and finish contribute significantly to the building's overall look and feel. In short, door and windows are the building's interfaces with the outside world, making interiors welcoming, safe, and comfortable. Parts 9. Staircases and lifts. Staircases and lifts are essential building components that provide vertical circulation between different floors in multi-story buildings, enabling easy and safe movement. Staircases are traditional vertical connectors consisting of a series of steps. They are usually constructed using reinforced concrete, steel, or wood. Stairs must be designed with precise dimensions for tread width, riser height, and landing area to ensure comfort and safety. They also need to accommodate building codes related to emergency egress and accessibility. The most common types of staircases include straight, dog-legged, spiral, and curved stairs, each selected based on space availability and architectural style. On the other hand, lifts elevators provide mechanical vertical transport, especially important in high-rise buildings and for persons with mobility challenges. Modern lifts are powered by electric motors and use cables or hydraulic systems. They improve accessibility and reduce travel time between floors. Both staircases and lifts must be integrated carefully into building design, balancing space usage and convenience. Safety features like handrails, non-slip finish, and emergency alarms are critical for staircases, while lifts require regular maintenance and safety inspections. Together, these components contribute to efficient, safe, and accessible movement within buildings. They connect the vertical layers of a structure and enhance its usability, making them indispensable for both residential and commercial constructions. In summary, staircases and lifts are the vertical lifelines of buildings, ensuring smooth movement and accessibility for all users. Parts 10. Finishing components. After the structural framework of a building is complete, finishing components bring the project to life by enhancing aesthetics, comfort, and functionality. Finishing includes all the surface treatments and installations that make a building ready for use, such as plastering walls, applying paint, installing flooring materials like tiles or wood, and fitting ceilings. These treatments protect structural elements, improve durability, and create visually pleasing environments. Besides aesthetics, finishes serve important functional roles. For example, plaster smooths rough masonry surfaces, providing a better base for paint or wallpaper and increasing fire resistance. Paint adds protective layers against weather and wear while allowing customization of colors and textures. Floor finish impacts safety, comfort, and maintenance. Tiles, wood, carpet, or vinyl can be chosen depending on the room's use and environmental factors. Ceiling finishes help with acoustics and hide electrical or plumbing conduits. Other finishing components include electrical wiring, plumbing fixtures, doors and window fittings, and insulation materials. These elements contribute to a building's livability, safety, and energy efficiency. High-quality finishes reduce future maintenance costs and improve occupant well-being by creating clean, durable, and attractive interiors. In conclusion, finishing components are the final touches that transform a bare structure into a complete, functional, and inviting space. They reflect the craftsmanship and attention to detail that define the quality of any construction project. Conclusion summary. In this video, we explored the essential building components in civil engineering and their key functions. From the foundation, which safely transfers loads to the ground, to the plinth and damp-proof course that protects structures from moisture, every part plays a crucial role. We learned how columns and beams form the structural skeleton, carrying vertical and horizontal loads respectively. Walls enclose spaces and provide stability, while floors and slabs create functional horizontal surfaces. The roof shields the building from weather, and doors and windows allow access, ventilation, and light. We also covered staircases and lifts, vital for vertical movement, and finished with finishing components that enhance durability, aesthetics, and comfort. Together, these components work in harmony to create safe, durable, and livable buildings. Understanding their roles is key for engineers, architects, and builders in shaping our built environment. Please don't forget like, comments, share, and subscribe to Civil Engineering Edge. Stay till next video, please.